Alright, if you're watching this video, you were absent for class this day, so we will do free body diagrams. I will show you how to do question number 4. The rest you will do on your own, and you can submit it to the hub when finished. Alright, question number 4. A 13 kilogram block slides at constant speed across a frictionless table. Draw and label the forces on the block, then calculate each of these forces. So this is going at constant speed, which means that the net force on this object must be 0. Make a little note for yourself. Constant speed, F net equals 0. So that means all the forces are balanced. So the first force we draw is the force of gravity. Draw a dot to represent the object's center of mass, and then you are going to draw an arrow that goes straight down from the center of the object and it points to the center of the earth, and you could label this F sub g for the force of gravity. Force of gravity is going to be equal to the object's mass, that's 13.0 kilograms, times acceleration, 9.81 meters per second squared. For now, with forces, we're going to leave off positives and negative signs. We choose the direction of net force to be positive. In this case, there is no direction, or there is no net force. So I'm going to let the arrows just represent direction. I'll keep the 9.81 positive. So if I do 13 times 9.81, I get the force of gravity acting on the object. That is 127.5 newtons of force, 127.5 newtons, and this goes straight down. This force is balanced by an equal and opposite force. This force supports the weight of the object. This is the normal force. It points up from the surface, straight up. It is always perpendicular to a surface. This F sub n is the normal force, and it must be equal and opposite to the force of gravity, so the normal force is 127.5 newtons. And this block slides at constant speed across a frictionless table. There are no other forces to draw or label. So I hope you found this video helpful. Thanks for watching and study well.